Hello, everyone. It's great to see you all here, and I hope that you're as excited as I am. My name is Esteban Hernandez, and I'm a specialist solutions architect working in the security and compliance space, covering EMEA. I will be joined here today on stage by Simon Waring. He's the head of information security for Starling Bank, who will be sharing their journey in securing their AWS environment. Our topic for today is architecting security and governance across your AWS environment. And I want you to think here about your AWS environment. How does it look like? How do you manage it if you're an enterprise or a startup or perhaps a government agency? What's the security baseline that you need to apply? What are your requirements? We'll talk about this a little bit, and then we will go into Starling so that we can understand how they have gone and implemented their security baseline as they were building the bank. Finally, we will talk about AWS's automated landing zone and why that is a great head start for implementing this security baseline. If you were interested in other security-related sessions but weren't able to make it, don't worry. These sessions are being recorded and will be available together with the content through our social media channels. Let's talk a little bit about how the AWS account is formed, its anatomy. When you first open your AWS account, it was empty. It was pretty much a blank page, waiting for you to start exploring the platform, waiting for you to start building on top of it. And while it didn't have assets deployed to it, you still benefit from the security of the cloud, with an extensive list of security and compliance programs and an extensive list of security controls that many of our customers in the highest regulated industries trust to deploy their most sensitive workloads. And also, together with every single AWS account, you get a root user. And that root user needs to be secured. It needs to have set a strong password to it. We need to enable MFA, and then we need to lock it up, as this is not the user that we intend to use for our everyday activities. What else do you get with the AWS account? Well, it is the highest level of segregation that you can get on the platform. And that stands true for security constructions like users, groups, resources, etc. And it's also the same level of isolation, independently if that account is owned by the same customer or if it's owned by different individuals. It is also the only true limit for API limits. Once you start deploying things into your AWS account, you know what you have deployed, you know how fast you're approaching to this, and you easily can understand if you need to request an increase or how to manage it. And also, the AWS account is the only way to segregate billing, because this encompasses everything, all of those assets that might not be taggable today, and things like transfer charges. And as you continue, you will need to create individual users. The first one with administrative rights, so you can finish the setup of your account, and a series of other individual users which will have a minimal set of permissions, just enough to make the job a task. And this is because you should be implementing the least privilege principle at this point. For this, you will use our Identity and Access Management Service, IAM. And IAM exists in a global context. This means that it's not attached to a specific region. Other services that also exist in a global context are things like CloudFront, our content delivery network, or other services probably like Global Accelerator, that is a networking service that helps to improve the availability and performance of applications. You can even think of the AWS console itself. And then you have regions. And of course, the AWS region is a geographical area where we have several availability zones. And we have this because you need to have data locality. And you need to have data locality because of performance. You also need to have data locality because of governance purposes. And something that we like to be very clear about is that whenever you place your data in one of our regions, we don't go around and move it. We don't copy it somewhere else unless it's under your specific instruction to do so. With 10-to-1 availability regions across the globe, it's a great way to launch products and services at the global scale. But how about if you already have a set of regions that you want to use? These are well-defined, and you want to make sure that services outside those regions are not used at all. Well, for that, you can create an IAM policy. And by using the components like not action to create an exception for those global services, and using a global condition like AWS requested region, we're going to be able to reject everything that is not coming from the list that we have specified here, in this case, EU Central 1 and EU West 1. That results in a much more manageable scope. In this case, it's also good to mention, we mentioned that we have 21 regions with 4 more coming. Starting with Hong Kong, we're changing the behavior here. Those regions were available to everyone immediately. Starting with Hong Kong, you will need to opt in to use the new regions. For that IAM policy to be effective, it also needs to be attached to every single user. Now, let's talk about account models. Many of our customers will start with a single account. Well, they will create a virtual private cloud, a VPC, and that's a networking environment controlled by the customer. They will deploy instances there. They will have different teams working together. And eventually, it might become a little bit overwhelming to manage access control around it. On the other side of the spectrum, we have customers with thousands of accounts. And this requires a high level of automation. And it requires a high level of configuration as well. And this speaks of the processes that they have implemented in order to be able to operate at this scale and the maturity level that they have reached. Most of our customers will be somewhere in between. And I would like to ask you here, where are you on your journey into a multi-account model? Are you still working in a single account, and that's covering more than enough your requirements? That's perfectly fine. But perhaps you have started thinking and you have started seeing some things that make you think that you want to split. So let me give you some reasons why a single account is not enough sometimes. We said that we have different teams that are going to be working together. And these teams are probably going to have dependencies between them. They will be deploying software. And eventually, they will start to get stepping on each other's toes. Or perhaps you have requirements for isolation. Maybe these teams need to work in a separated way. Or maybe you have different applications with different profiles. And maybe that difference in profiles means that they have different security profiles. And for that, you will need to have a set of different security controls. Security controls can be defined in different accounts, and that means that you can be more restrictive where you have to and more flexible in other places. Let's think, for example, that you have to comply with PCI. And as part of that, you need to handle cardholder data. It's a much better story to have that in a separated account where you can apply all of the controls that you need, as opposed to try to manage everything there. Or perhaps it's down because you have a group model in your organization and you have different business units that cannot interact within each other. They need to be separated. Or perhaps even that separation is to go into the billing side so they can understand what the cost is of their different deployments. If you have started to think that it's a good point to leave that single account and move into a multi-account architecture, you need to set some goals as well in order to be successful. So the first goal is that it has to be automated. We want to make sure that those teams that are collaborating don't become the bottleneck. And that's because we want to be scalable. We want for our model, our framework, to be able to work and grow with us. And for that, we need to enable them to be self-service, because we want these teams that are developing business solutions for our company are able to deliver them on time and as fast as they can. And also to enable that, we need to have guardrails and no blockers. Those times where a security function or any central function for that matter will say, no, that cannot happen, just don't code it anymore. We need to be flexible, and that speaks about the mind shift that we need to make. We need to be able to trust but verify. And to be able to verify, we need to be able to have auditability in order to understand what has happened, in order to understand what were the causes that took us to that situation. But all of this won't mean much if we're not flexible. It doesn't matter how much we think about it, there will be use cases that haven't been catered for in our model. And that means that we need to adapt. Remember that case about PCI compliance? Well, maybe you didn't have to comply with it before, now you have to, and now that's the point to think on how you're going to segregate that information. So what account security considerations you should have? Well, we spoke that every single AWS account has a root user that needs to be protected and secure and locked up. We also spoke about how important it is to have visibility of your environment. And for that, you will need to enable things like AWS CloudTrail that will be recording API activity on the platform. You need to enable things like AWS Config in order to track changes in configuration to assets that have been deployed in the account, or even Amazon GuardDuty, which is our threat detection service. And you also need to be able to define the different roles that are going to be interacting in this space. Who's going to be a developer? What permissions that developer needs to have? How are these going to interact? Who's going to be doing QA? And once you have mapped those permissions into your AWS account, you need to define how they are going to authenticate. Are they going to be using IAM users directly? Perhaps they are going to be using cross-account roles. Or maybe they will federate straight into the account. And that's a recommendation, because most likely you already have a directory or an identity provider that it's joined into your joiners, movers, and leavers. And that's something that you want to leverage, because that's an easy win. And you need to be able to establish the right access for the security function. The security function is to be able to have visibility and audit the environment. And it also needs to have the right level of access to write and take action in case something goes south. And you need to be able to identify what are the different requirements that you will have. This will translate later into guardrails. So that means that if you already know that you need to have encryption at rest, you will apply that encryption at rest by using our key management service with KMS to every single EBS volume and also to every single S3 bucket that you create. What accounts should I create? Well, we start from the top. And at the top, we have the AWS Organizations Master Account. From there, we go and create the log archive, followed by the security, shared services, and networking account. We need a place where we can deploy our billing tooling. And we also need to have a space for experimentation. That's where our Sandbox environment is going to be. Then we have the SDLC accounts, where we will finally deploy our applications. And finally, we need to have others. And others is catering for that flexibility that we spoke at the goal setting step. So let's start with AWS Organizations Master. It sits at the root of the tree. It's not going to be connected to anything. It's where we will host our service control policies. And it's where our consolidated billing lives. And by having that consolidated billing there, we can understand what's the volume and start opening things like thinking about volume discounts. It needs to have minimal resources running on it. Apart from certain things, it should be of very limited access. And that organization's role that gets created in order to help deploy things also needs to be restricted. So talking about service control policies, part of AWS organizations, we spoke how important it is to have visibility. Well, we can create a service control policy that gets applied at the account level in order to stop anyone, even the root user, from disabling or stop logging for CloudTrail. Because the last thing that you want to have is a threat actor going into your environment, turning it off, taking some actions, and then turning it on again. With this, we can make sure that those things won't happen. Or perhaps you can use something like granular SCPs. That is something that we released recently. And it helps us to make full use of the policy language that comes with SCPs. In this case, we have created an admin role that has been deployed to the accounts, and we want to make sure that only the admin role is able to make changes and no one else. For that, we leverage things like enabling the resource portion of the policy, making sure that that's the role that we want to protect, create some exceptions, and using a condition to make sure that the admin role is able to make those changes. Now that we have support for these things, we can also promote that initial IAM user that we needed to, that IAM policy that we spoke about at the beginning, and promote it to an SCP. And that means that we can apply it at the account level, or we can apply it to the whole organization. And that becomes much more manageable. Then we have the core accounts. We have spoken that we have developer accounts. We are not going to go there yet. The core accounts are those foundational bases. They will become the building blocks that we will use. They occur only once per organization, and they will host those things that help the organization to work. They have their own development lifecycle, even though they appear as single boxes in this model. So let's start with the log archive, going a little bit deeper into the detail. The log archive will make use of a version Amazon S3 bucket that is going to be restricted and will require MFA in order to be able to delete. So that means that whenever someone tries to delete, they need to authenticate with MFA. And if it's deleted, it's OK, because this is in a segregated environment with a version S3 bucket, so we can recover it. Anything that goes there, like security logs, it will become a single source of truth for the environment. And if we see any human logging in, that means that alarms should go off, because this should be of very limited use, and only automated portions should be existing in that account. But we can provide read access whenever we need to. From there, we go to the security account. This should be owned by the security function. It will send its security logs to the log archive. It might be connected to your on-premises data center. And it will depend on where is your security tooling deployed. If it was deployed on your on-premises data center, then it needs to have the connection. Maybe you deploy that directly on the cloud. Many customers decide to do that directly on the cloud because they know that they can scale together with it in order to handle whatever is happening at the organization level. It will become your GuardDuty master, and it will contain those cross-account access that the security function needs to have. A read access role to every single account in the environment so they can have auditability, and a read role and a write role in order to take action. However, this should be done through automated tooling. This is not the place where you will grant access to other people, other functions, to jump from one account to the other. There should be a federation service that is already doing that function. It could be used as a break glass in a break glass situation. However, that's not the intention here. And of course, because of these things, it needs to be of limited access. Then we have the shared services account. So the shared services account will send the logs to the log archive. It will be connected to the data center because there is likely a dependency there with a directory service. It will be connected to the security account. And here is where we will host those things that help all the organization to work. So this is where we will be deploying things like DNS, our LDAP or Active Directory, our shared services VPC. This is also where we will be placing our deployment tools, things like our AMIs, our pipelines, and our scanning infrastructure, because I'm sure we want to know if there are EC2 instances that are not being used, or if there's a snapshot that was deployed and has been hanging there for years and could become a potential security problem. It will also hold the monitoring tooling, and it should have limited access. It should be owned by the function, the central function that is in charge of all of these tools. And then we have the network account. This, of course, will be owned by the network team. It's likely that your network team is different from your other central functions, and that's because they have a clear understanding of how your network works. It will send the logs to the log archive as usual, but it won't be connected to anything else. It will host things like networking services. It can host things like Direct Connect. And even though it's hosting Direct Connect, and I already mentioned that it's not going to be connected to other things, that's because Direct Connect has the capability to place virtual interfaces out to other places. And of course, you could guess this one is of limited access. And then we have the developer sandbox. The developer sandbox still has dependencies. We need to have those logs just to know what's happening. But it won't be connected to anything else. And the reason for that is because we want this to be a place for innovation. This is something that we can assign to developers, architects, operations people, and they will use this to learn and to experiment. But we need to add some restrictions, because these are still company resources. So if we add a fixed spending limit, that will make it much more manageable. This will be autonomous, and of course, this is a place to learn. Then we have the team group accounts. And the team group accounts are going to mimic your development lifecycle. And this is where we start talking about the level of isolation that they need. And the level of isolation is going to be dictated by the teams that own it. So what does the team need to do? What the function are they providing? What are their requirements for the... It needs to match your development lifecycle. And we encourage here to think small. The smaller that you think here, the better and easier it becomes to segregate. If we start with the development account, as you can expect, it sends the logs to the log archive. It's connected to the data center to a development network, if that exists, and it's connected to shared services. It's intended to be a place to develop and iterate quickly, but it's also meant to be a collaboration space. On the Sandbox space, we're thinking of personal accounts. Here, we are talking about a team account where everything comes together. It's one stage of the SDLC, your development lifecycle, and we are considering a 3-stage development lifecycle. But by all means, if your development lifecycle is bigger, it has 5 stages, you call it alpha, beta, or gamma, it doesn't matter. It needs to be a function of how you decide to build this. Then we have pre-prod. And for pre-prod, the story goes again, archiving the logs, connecting it to the right places, pre-prod network on the on-premises data center. It is production-like. And this is where we make that shift. This is not owned only by the team, it's also co-owned by the operations team and the security function. And we start to apply more control to it. It's where we do our staging. It's also where we do our testing. And the deployments cannot be manual. We need to start talking about automated deployments for every single thing here. And then we move on to production. And in production, same story, connection to the right places, logs in our centralized location. This is where we will be hosting our production applications. And the only way to actually deploy and get there is by being promoted from pre-prod. Is, of course, as we move closer to production, of even more limited access. So maybe our developers won't have any access here, because everything should be done through automated deployments. And as we continue iterating, it will become apparent that some things just belong together. They might not be as generic enough that they need to go into the shared services one, but they might have a set of functionality that is important for a specific team. So we have the team shared services account that will be connected to every single account that needs to have connection to it, that has a common service with it. It will hold the logs. It will grow organically as the organization grows. And that means that at the beginning, it might be less important, but as these things become clear, it will become more important for the team. It will hold things like product-specific common services. Maybe it's a data lake where you're working, or just common tooling. So how is your innovation pipeline going to look like? We spoke about the sandboxing environment, and that's where things start. That's the ideation process. From there, you can move into a proof of concept, a specific account that you have dedicated to that. And once you're happy with it, you can promote that into your dev environment. And from there, it goes to dev, to pre-prod, and production finally. Or perhaps that's not the way you want to work it. Perhaps you want to jump straight from the developer sandbox into the development environment. It's all down to how formal is that thing that you're trying. Maybe you're just experimenting, and that's fine. Or maybe you have a more formal initiative already there. We need to keep flexible, as we have said in the past. Compliance requirements might change, and that means that we can create segregation for those specific cases. We mentioned several times isolating cardholder data in the case of PCI. This also holds true for things like personal health information in the case of HIPAA. Now, it's time for me to hand over to Simon, who will share how they are managing security on AWS. Please, help me to welcome him today.
Thank you, Esther. Hi, good afternoon. Today I've been asked here to come to talk to you about how Starling manages security in AWS. More specifically, how we build and manage our security for our banking platform. For those of you who don't know Starling, we're a UK challenger bank. In fact, we were the first cloud-based UK retail bank to get a banking license. Only just, though. From a technology perspective, we are a cloud-native, mobile client-only retail bank. We offer a number of fully featured accounts, including personal current accounts, joint current accounts, business current accounts, with integrations into all the major payment services and schemes. We also offer Apple Pay, Google Pay, Fitbit Pay, and a few other pays. And our aim is to put you in charge of your finances by providing you real-time updates on your spending and giving you the tools to take charge of your finances. This slide here gives you a brief history of Starling and how it started. In January 2014, our founder and CEO, Anne Bowden, decided she wanted to build a better bank. By the second half of 2015, we were testing and building technical prototypes of the mobile app and the banking platform. The banking mobile app went into alpha in 2016 and then moved into beta before our public launch after we were granted our banking license in April 2017. We must have been doing something right, because in March 2018, we were awarded the Best Bank Award at the British Banking Awards. Since then, we've gone on to win a few more awards, and some of those are noted on the bottom of that slide. These are some of the services we currently use from AWS. There are quite a few there, and I'm sure over time we'll start using more as AWS make them available to us. Security. When we started our journey of building the banking platform, we knew we had to get security right from the beginning. Security of the platform was, and still is, one of the most important cornerstones of the bank's security posture. We took time to understand the features and services we had on offer to us from AWS, and we worked closely with our account team and SMEs from within AWS to make sure that we were taking the right path. Obviously, we had to comply with the relevant regulations and legislation and in order to obtain our banking license. This was achieved through collaboration. We worked closely with the regulators, our auditors, the AWS team, to make sure that we were all on the same page as to what we thought the risks might be of developing a banking platform in the cloud, because this was new to quite a lot of us. This process was iterative for the entire process of mobilization, all the way until we achieved our goal, which was to get our banking license. Predictably, we founded our approach to our architecture and building of our banking platform on the well-architected framework. And you'll recognize some of the security principles there on the slide in orange. In addition to those principles, we've also adopted some of our own, and you can see those in blue. Keeping it clear and simple was not just to make it easy for me, but was also to allow us to communicate to new starters, to third parties, stakeholders, exactly what we were doing and how we were doing it. We also didn't want to make it over complex, which would put us in a position that we might make mistakes. We also wanted high visibility of privileged activity. We don't just produce logs and produce alerts for a small number of people. We let everybody know in the organization what somebody's doing if they're doing something that needs privileged access. And you'll see more of that in some of the other slides. And we also try to make our engineers self-sufficient. We don't want them to have to go through onerous processes and controls just to do their job. Again, we'll go on to some of that in some of the other slides. In order to maintain the integrity of our AWS environments, the first thing we had to do was build out our identity and access management implementation and configuration. Adopting the MultiAccount Model, we were able to define clear role-based access controls, perform segregation of duties, and not have to insist that anyone had standing privileged access. We were also able to integrate with CloudWatch and GuardDuty to provide alerting and information. Following the multi-account model, as you can see here, this is an early diagram of how we implemented it. Our engineers authenticate to the single account on the left, and then assume a role in the target environment on the right. Using this model, we're able to have clear and appropriate controls, but we are also able to automate that privilege management. We've also got clear segregation of duties. As you can see here, we've got 3 main columns here of roles and responsibilities. But there's a clear demarcation between those that configure and manage access control and those that assume it. We also have a principle where we try to make things as visible as possible to everyone within the organization. So if you walk around our office, you'll find many screens with monitoring and alerts on, and anyone within the organization can go and look at the metadata within the AWS console and see what's going on at any time. Back to our automation of privilege management. What we've done, and you can see here, is our internal Slack channel we use to manage our privilege management. We don't require people to go through an onerous process. What we're doing here in the example is you can see that Joanna is looking to assume the role of deployer in the production environment. She's also provided the justification for that activity in the reference she's made there, which is actually a Jira ticket. Now, Zolt, who is another engineer, who's probably been working with her on this particular piece of work, hence there's only a minute between him, the request and the authorization, is aware of what Joanna's trying to do and considers it to be appropriate and will be watching over what she's doing. So at the point that Zolt's granted Joanna that permission, she can now then go to assume the role in the target environment and perform what she needs to perform. When Joanna's finished what she's doing, she can either manually, through this process again, through the bot that's behind this chat channel, she can revoke her privileged access, and if she doesn't, and what's happened in this case, and you see on the bottom line, is that the bot has actually revoked her access because it's timed out. And here we have how we bring it all together. As you can see here, this is a high-level schematic of our logging. It's slightly more complex than this, but this is good for this purpose. As you can see, our application logs, our OS logs, our VPC flow logs, and Elastic Load Balancer logs are all fed into Elasticsearch. This allows all of our engineers, in fact any of our staff, to surface alerts and logs for anything in our environment without actually having to go into the environment. So it keeps them out of it and we don't have to give them special permissions. It also allows us to alert on specific messages and instances of events, and we publicize those and make them visible using Slack, and then we provide the right notifications to the right people in a robust fashion using PagerDuty. So, our monitoring and alerting allows us to make sensitive activity very visible and transparent. We're using Slack for notifications as well as email, and we're using CloudWatch to monitor and alert on account best practice violations and failed logging attempts and other things like that. Our most recent monitoring and alerting tool is GuardDuty. And GuardDuty is not our first machine learning monitoring system, but it is the system that we use today. GuardDuty is good at giving us full visibility across all of our estates very quickly of all activity that we don't want to be happening to do with our API access and network services. GuardDuty also integrates into CloudWatch. But if you ever looked at a raw GuardDuty message, there's a lot of information in there. So what we've done is we've integrated it into CloudWatch. The top right-hand screen that you can see there is the configuration that makes CloudWatch trigger on GuardDuty events that are medium severity or above. Those alerts are then triaged by the Lambda function below it to pull out the relative and relevant information and format it in such a way that we can form the emails you can see on the left-hand side to be sent to the relevant parties. That email contains all the information that we need to take the next steps, to make a decision on where we go next, and it also provides links to information that gives us more granular detail about what's been going on. So, we've implemented our monitoring, but how do we make sure it's working? Well, we monitor our monitoring. We have a number of fire alarm tests that run on a regular basis to make sure that our alerting is working end to end. And you can see an example on the left-hand side of the screen there. So we know that we should be receiving these alerts at regular intervals, and if we don't receive them, there's a process to go back and look and see what's happening. We also have a number of the screens, such as the ones you can see on the right-hand side, that are monitoring. We have about 40 of these in the office, and we're getting more. We like to monitor things. These monitor all the aspects of our environment, including the alerting and monitoring. So we're always aware of what's going on. And again, we're trying to make it as visible as possible. So, having implemented our security, of course we need to make sure that it works. We have two main streams of testing that we get involved in. Our internal testing is performed via our internal testing function, where we're penetration testing and security testing everything that's being developed and put into production before it goes into production. We're also looking at unhappy paths, so we don't get unexpected events through edge cases. We're also doing threat modeling to ensure that we've considered all the threats that we should. We also do independent testing using multiple independent security testing companies. This is to make sure that we don't get a skills gap between one company and another when they come to the testing. And also, it provides us independent assurance of what we've been doing is right and working, not just for ourselves, but for our independent, our third parties such as the regulators, third parties that we do business with. We also take an approach with our testing where we don't just let the testers sit on the outside of our environment and look in. We actually place them right in the middle of all of our networks, every VPC, every network, to make sure that all the controls that we've got in our defense in depth are working as designed and not reliant on perimeter controls themselves, and then find out that your internal controls don't work should something go wrong. Of course, all of the significant findings from our testing are all managed through our formal risk management framework to make sure that we deal with them consistently and nothing's left to go to the side. And at that, I thank you for listening, and I hand you back to Esteban.
Thanks a lot, Simon, for sharing that story. Now, coming back to our multi-account strategy and approach, this is where we left things. We spoke about the basic structure, what it needs to have. We call this a landing zone, and this is a full picture of it. However, we like to listen to our customers. And our customers told us that they wanted to have something to make it easier to create this type of architectures. So the AWS Automated Landing Zone was created. It is an easy solution to deploy multi-account architectures that take care of the identity and access management, the network design, setting up those permissions for the security functions. It's trying to help make things easier. And the way it's doing that is by leveraging the automated deployment technology of AWS to create that basic account structure by using AWS organizations. So we'll have our security services, we'll have our shared services account, we'll have our log archive, that all of it will be created automatically. And of course, you can always go and build all this by yourself, but we believe that this is a great way to start. Because most importantly, it also includes an account vending machine. You can think of it as an account factory. And what it's doing is that it's wrapping those AWS organizations API calls to create a security baseline for the accounts that get created. So in this way, you make sure that those logs, Cloud Release Enable, you will keep a local copy for operational purposes, and another copy will be sent to the log archive. That access for the security function will be deployed automatically through this. And it creates the basic plumbing that is required for it to work. It's not going to do everything, but it's going to get those part work there. So you can focus in adding doing additional value-added decisions around what you want to build. And by all means, don't do this all by yourself if you don't have to. So it's going to get us partway there, and this becomes evident by looking at this next steps typical checklist, where everything that has been crossed out is provided by the automated landing zone. You can also see this action plan, where we can see the same, and the same goes for this common checklist of implementation. So we can start checking also for those guardrails about S3 bucket encryption or even EBS encryption, so we know that the control is being implemented and that we can monitor for it. Putting it all together, we've spoken about what the AWS landing zone is. Now we also need to start thinking about the account metadata. Who's going to own those accounts? What function do they need to provide? What stage of the development lifecycle they are going to belong to? What's the cost center that these are going to be charged for? And we need to define the policies. And that policies will be composed of guardrails. So we can understand when we need encryption on ABS, or maybe if that the networking constructions that will be used for VPCs won't require an internet gateway. As we have talked about this, defining those policies is work that still needs to be done, because we also need to think about policy deployment. We also need to think about policy enforcement, remediation, and notification for when things go wrong. All of this work to define those policies is something that is still not provided by the AWS landing zone. It's something that you need to think about because it's going to be in line to your specific use case. With that in mind, I would like to finish here and thank you all for attending this session. I hope that you found it useful. One last thing, just a gentle reminder that we want your feedback. We thrive on feedback, so we want to listen and learn what we can do better for next year. The feedback is provided through the app, and thanks again. Thanks, Simon, again.